by that, I mean, you're really only going to use spherical coordinates if the region that you're integrating your triple integral over has something to do with a sphere, right? It's spherical in some way. So we've got a little hit list of how you would approach the question. The most important part is this part, step one. If you get step one right, you're pretty much broken the back of the question, in my opinion. Okay, you've got to do some trig integration, but hopefully that's just calc 2 stuff with variables theta and phi, typically. So you get your question. You're going to find the limit of integration. So you're going to find out what the range of rho, and what the range of theta and what the range of phi are. Now, if it's a totally untouched sphere, which for some blinking reason they're calling a ball, well, I mean, it is a sphere, a ball's a sphere, then these would be the general restrictions that you would use. So here's my first guy, and these are very similar to questions 7 and 8. You've got this expression dv, so what does B look like? Well, it's going to be rho, theta, and phi. Okay. Now, since it's a normal sphere, and the radius is 5, that tells me rho goes from 0 to 5. That's what you get with a sphere. When it's a complete sphere, you get theta from 0 to 2 pi. And then these are things that you're just basically remembering. And what do you get when you have a full sphere? What do you get for phi? From 0 to what? Pi. Can you imagine that you start off in the vertical position, right, which is phi 0, and then you rotate it down to below. And that's all you need. And the reason you don't need the rest is because theta does 0 to 2 pi, theta scrolls around the rest. So if you imagine this being rotated all the way around, so you generate a sphere by only needing 0 to pi. That's step one done. Convert everybody into rho, thetas, and phi's. Right, now something like x squared plus y squared plus z squared is pretty easy to do. I'm just writing down the original question just for your notes. Rho goes from 0 to 5. Doesn't matter. Theta goes 0, 2 pi, and phi goes from 0 to pi. Right, x squared plus y squared plus z squared simplifies down to rho squared. dv gets replaced by a rho sine of phi, and d rho, d phi, and a d theta. And can you pretend I switched the places of these guys, because based on the order, at least I've written these three, the middle one should have been phi. Well, that would be step 2. Right, and step 3 is evaluate. So I'm going to have rho cubed. I'm going to have this guy, but it is separable. So I'm going to do rho equals 0 to rho equals 5, rho cubed. Sine of phi. And phi is 0 to pi. And theta, well, you're just going to get theta equals 0 to 2 pi, and you're going to get 1 d theta. Right, and...
Professor?
Yes?
For the dv is rho square sine all the rest. But here, the z right here is also rho square as well. So should not be
Correct.
rho to the 4th.
You've got a
One.
row 4. Let's check what you got. Would you agree that this piece here is rho squared?
That's correct.
Oh, I see. I didn't write the square down there. I hear you. Yeah, I just didn't transfer well. Is 4. Get the answer, get the answer, get the answer, done. That's basically the question finished. And dots for you to finish. Notes over here. This is one similar to question 9. We're being asked to find a triple integral over E. Do you know that letter of the alphabet? They keep switching it. It's B when it's a ball, it's E when they feel like it, and it's R when they feel like it. And who knows, if they go on often enough, won't they probably do a triple integral over P because they felt like it? So I'm not too concerned about that. It's going to y squared, z squared, dv. Okay, let's figure out who E is. Oh, I haven't told you who E is. E is described as above phi equals pi upon 3 and below the sphere rho equals 1. Kind of cryptic. Rho theta phi. Okay, so if you're talking about a sphere below rho equals 1, I'm assuming all you're talking about really is that. Now, if it was a complete sphere, which it could be, you got that, and it's going to be above pi upon 3. And so that description of what region E is, above phi, pi upon 3 gave me this, and below rho equals 1 basically gave me that. So I'm going to have, what order am I doing these darn things in? I'm doing theta at the end. Okay, so theta is going to go from 0 to 2 pi. I'm going to do phi in the middle.
So
Yes.
phi wouldn't be like pi upon 3 to pi because it says it's above pi upon 3.
Okay. Let's show you what's going on here. When you do the above part, we're talking this piece here, aren't we?
Yes.
Well, at this position here, phi is 0, and at this position, phi is the pi upon 3. So the above is 0 to pi upon 3.
Okay.
But that was a good question, because I just said that like it was obvious, and it's not.
So if we get that phi is pi upon 3 above a pi, it says phi is above a certain value, we
Is
would
that you
assume
that's
that it
doing that
yes
annoying?
yes it's the desk phone.
Okay.
So if it says like phi is above pi upon 2, we would go from 0 to pi upon 2.
Yeah, and if it said below, you would do pi upon 2 to pi.
Okay, so if it says it's below, it goes to pi. If it says it's above, it goes from 0 to the value.
Yes.
Okay.
Right. Yep, the nice
you.
concise way of saying that. And we got rho is going to be 0 to rho equals 1. Okay, I get y squared and z squared. That's not going to be pretty. Y squared is rho squared sine of phi sine of theta squared squared. times z squared, which is rho squared, cos squared. And then I'm going to have yet another rho squared sine phi, and then I don't even have enough room for the guys that come later. So I'll squeeze them there. Good grief. I get 0 to 2 pi, 0 pi upon 3, and a 0 to 1. And we have got a mess here. I got this guy, I got this guy, and this guy. So I got 6, I think, of them. I got this guy and this guy, so I'm going to do sine squared this. Oh, one more. So sine cubed this. Cos squared this. And what have I got in the thetas? Oh, just a sine squared theta. And then we're going to go rho phi theta. Okay, is this variable separable? Can this be separated into 3 distinct integrals? Yeah. And the reason we can get away with that is everything's multiplied, right? Add and subtract tends to kill this process, but not this fella. So I could do 0 to 1 of rho to the 6. Check. As far as the phi is concerned, that's 0 to pi upon 3. I'll do a sine cubed with a cos squared. And I'll do a 0 to 2 pi of sine squared. Okay, going to be stopping this one quite shortly because I want to get as many as we can. Let's talk about process. Would you agree that's a power rule? I believe you get a 7th out of it. How are you going to take care of sine cubed cos squared? What technique?
U substitution.
Right. And what would be the correct substitution in this question?
Sine phi.
I'm shaking my head. Not just because I want to shake my head, it's not sine.
There isn't a secant in there, is there?
No. It's a U sub, but it's not sine phi. What is the U sub?
Sine phi?
That's the same thing that I said no to. What's the sine? What is the U sub in sine cubed cos squared?
I guess it has to be cosine then.
It does have to be cosine. The fact that you're not comfortable with that is a little bit concerned. I know it's Calc 2 and Trig's a horrible thing, but you really need to get this sorted out because who knows what the next one's going to hit you, and you're just going to spend ages getting all upside down and back to front. It is one or the other. When one of them's odd and one of them's even, you always pick the even one. Let's try, just imagine what happened if I did sine. If I did a U sub of sine phi, won't I kill off only one of the cosine phi's and there'd be a cosine phi left over, which would be bad news because you couldn't get rid of it. On the other hand, if you pick cosine, won't it kill off one of the sines? Sure, there's going to be a sine squared left over, but can't sine squared be called 1 minus cos squared, and that's how you get around the problem. So only one of these two works. Now, if they're both odd, let's suppose that's a sine cubed and that's a cosine 5, right? What U sub do you use when they're both odd?
The lower exponent.
I'm shaking my head again.
The higher?
Yes. So be aware of, I mean, I can't see you not getting U subs with powers of trig in these questions, right? Aren't they kind of naturally going to generate things like that? So get used to how to tackle Calc 2 integrals of powers of sines and cosines. You're only going to typically see sines and cosines, right? So they're the ones you're going to have to focus on. This fella here isn't even a u-sub. What's sine squared? How do you tackle the integral of sine squared? That's a better question.
Just change it to cosine.
Yes.
One, like
Negative
1/2,
cosine, right?
1/2, 1 minus cosine. Yeah.
That guy. Turn him into that guy. So if that's what you mean, I agree with you. Right. And that'll become a half minus a half cosine 2 theta, and off you go. So you are going to have to deal with at least 2 of the 3. You're going to have to deal with trig integration and the complexities that generates. At least the row is just going to be a power rule, isn't the row going to be a rho squared, rho cubed? It's just going to be a power rule. So, little thing to keep an eye on. Oops. Next one is like question 10. Got this fella. And E lies between the spheres x squared plus y squared plus z squared equals 1, and x squared plus y squared plus z squared equals 9. Okay, so what's my order? I go theta, then I do phi, and then I do rho. Okay, we need to set up these limits of integration here. You got a big sphere, you got a little sphere. I can imagine what that looks like. Imagine a big ball, and inside there's a spherical hole. So what would be the restriction on the rows to generate that particular solid?
Wouldn't it be 1 to 3?
Yes. Now, there isn't any other restrictions on these spheres, so it's a whole sphere apart from that. And I like whole spheres because we can just write down the 0 to pi and the 0 to 2 pi guy, right? And that's it done. Now, the x squared plus the y squared is basically these two squared. Ugh, okay, so it's going to be x squared, which is that guy, plus y squared, which is all of that. And then, don't have enough room, followed by a rho squared, sine phi, a rho, phi, and a theta. Okay, I'll cut down on the labels to give myself some room. God, this is a mess. Okay, forget about that for a second. Rho squared, sine squared, cos squared, plus rho squared, sine squared. Anything you can do style points with that?
You can factor out rho squared, sine squared of phi, and then cosine squared plus sine squared will be 1.
Okay, can you see that, guys? If you, what she said is bang on. Rho squared, sine squared is a common factor. Wouldn't you have a cos squared plus a sine squared, which is 1? So to save room, I'm going to do rho squared, sine squared, times 1, followed by a rho squared, sine, followed by a d rho, d phi, and a d theta. Are we happy about where that thing came from? Out of here. Cool on that. Right.
Yes.
Now, not a lot to do, but a little bit more. I think the back is broken here. That and that gets me 4 of these guys. That and that gets me the cube of this guy, d rho, d phi, d theta. Variable separable again. There are no thetas, so 1 d theta. This guy, and I hope I got the right version of this fella. Okay, techniques of doing it. This guy's a power rule, which is pretty much what they always are. Wouldn't this one just be 2 pi eventually? Okay, Calc 2 question, how do you integrate sine cubed? This seems to be the bugaboo right now, how you do some of these integrations with the trigs.
That would be by parts.
Interesting. If you do integration by parts, how are you going to split it? I'm not saying you're wrong until I hear what you want to do.
I'll probably do U be sine square, and then dv be sine of phi d theta. I'm d phi.
Oh, okay. I suggest strongly you don't do that. I'm not saying it wouldn't work. I've got a feeling you're going to scenic route, which just means I think it'll take you a long time because you're going to have to integrate a sine squared or differentiate a sine squared, and that itself will lead into uglier terms. So I'd be wary of that. So integration by parts could work. I'm not saying it won't, G, but I suggest you shouldn't do it that way. Okay, what other alternate techniques have we got?
Could you take a sine squared and change it into 1 minus cosine squared and then distribute the remaining sine through?
Don't distribute it. Everything up to the distribute was, I would say, was a really good move. Just leave it like that for a second. Think of what technique.
Use substitution, I guess.
Yeah. And now it'll work. You'll end up with, oh, I'm not sure, either 1 minus u squared or negative brackets 1 minus u squared, but it'll be a doable polynomial and you'll be able to make it work. So a little bit rusty still on the trig, but every time you see one, it's, you know, it's like riding a bike. Oh God, yeah, I remember. That's what you do when there's an even and an odd and all the other little tricks of the trade. But at this point here, I would assume you could just continue it and finish it. Is that one off our list? Triple integral of just x squared. Well, this is a little bit interesting. E is x squared plus y squared plus z squared less than or equal to 16, which is basically just telling you it's a sphere of radius 4 and everything inside it, which is fine. And that guy. So if I want to describe E, rho theta phi. This pretty much just tells me that, and that's good. It tells me something I can use. Now, what about the y greater than or equal to 0? If you imagined it being a full sphere, wouldn't it be, at least on the xy plane, wouldn't it be a circle? You imagine projecting the thing onto the ground. A full sphere would look like that. But if you're doing y is greater than 0, aren't you only using that part? So how do you describe that part?
Just theta as 0 to pi.
Great. And that one is already 0 to pi. So the restriction here was in that. Everything else was being left alone. If you don't do anything to it, then give them their standard values. If you restrict something, in this case, you did that. Suppose I changed it. Instead of y greater than 0, suppose I had said x greater than or equal to 0. Then,
Negative pi over 2 to pi.
yeah. Suppose I had said first octant. Wouldn't it just be that piece? Remember, in the first octant, x and y are both positive. So in this case, that's the restriction, 0 to pi. Right, and you put the pieces together then. Keep having a look at my notes to figure out where I'm putting thetas. There we go. 0 to pi. 0 to pi. 0 to 4. X squared becomes rho squared sine squared phi cos squared theta, followed by a rho squared sine phi, and then the usual rho phi theta guy. Do you see these guys separate? Let's see how they separate. I'm going to have from 0 to 4, rho to the 4. I got a sine squared phi. That's all I've got. And I have.
Wouldn't it be cubed because you have the
you're
sine
right.
phi?
You got it. There he is. And I got a cos squared. You're right. Okay, so we've got a cos squared on its own, a sine cubed on its own, and this fella. This fella is going to be a power rule. Nothing surprising there. Okay, we've done a sine cubed. Didn't we do a sine cubed a minute ago? Yep, we did. Remember how we dealt with the sine cubed?
Yes.
So call it sine 1 minus cos squared, and then do a u sub. Oh, my phi's have turned into the kind of curly phi. It's still a phi. And this fella, we've done this fella before as well, at least something like him. The good news is once you've seen something, there's a good chance you're going to see it 2 or 3 more times. So once you've figured out how to do a cos squared or a sine squared, you kind of know how you do them. But once you've seen a sine cubed and a cos cubed, you know how to do them. And if you do combinations of sines and cosines, which will happen, hopefully, you'll say, I know how to do them.
Wait, does that cosine squared theta change? Should that switch to a sine 2 theta, or does it stay the same?
That there, it stays the same.
Okay.
The trig identities are cos squared and sine squared. And the cos squared has a 1 plus here, and the sine squared has a 1 minus here.
Okay.
If you coming across things like this, that you're a little bit rusty, do what I would do, because I got a horrible memory. Get a nice piece of paper and you write the darn thing down there. So you say, okay, yep, write it down. I have something here. I can find it. Show you this for a second. If you want to, I won't try and even write this down, but if you go back to this video, you could probably pause in this page. Here are some trig identities that you sometimes would use. In our particular world, it's really going to be these guys, isn't it? Because we don't really do secants and tans in spherical. So it's got the usual conversions. Okay, am I okay at leaving this guy here and doing the old ... and you finish off each one separately and then multiply them up?
Yeah.
Okay, good. Because there's a fair number of permutations in these questions, so I'm trying to cover as many situations as I can. Oh, a first octant one. Oh, good. This is like question 12. It's going to be e to the x squared plus y squared plus z squared dv. And E is described by a sphere, technically the inside of a sphere, and it's in the first octant. Now this bit tells me rho. The first octant, isn't that the only bit of the sphere that gets used? Because in the first octant, the x and the y's are both positive. Now to generate this guy, don't you have to do thetas between 0 and here, pi upon 2. Now you agree? Now, if you are doing an entire sphere, this is me looking at the values of phi now. Z-axis upwards, agreed? Phi equals 0. Don't you rotate only to here. So you don't go, getting this up, you don't go from here all the way down, which would generate the entire sphere. You only do a piece of the sphere. And that is why this guy is also phi upon 2. Does that make sense? That you need both these restrictions. I'm trying to draw this and I'll murder it. But isn't the thing that we are dealing with just this little 1/8 of a sphere? Can you imagine that you had a nice big birthday cake and somebody made it in the shape of a sphere, and you just cut one octant, right? The positive octant. This octant, that's the bit in the XY plane. And aren't you going from here to here, right? From 0 to pi upon 2. And that's the rotation or the movement of phi. So hopefully I've argued enough about that to work. So
Yeah.
we're going, yes.
Sorry, in the previous one where we had only the hemisphere, only the boundaries of theta changed, and the boundaries of y what makes the difference there?
In the previous question,
Yeah.
let me find it first. I think we're talking about 11.
I think so, yeah.
This one.
Yeah.
So the orientation, I'll try and draw this down. The orientation would look something like this. You're allowing y to be positive, right? But only positive. So if I can imagine what the sphere would look like, wouldn't it just be, no curvature on it, wouldn't it be this right-hand side piece?
Yeah.
And if it's a right-hand side piece, won't phi start at 0 and finish at pi?
Okay. So for a half circle, phi at pi.
In
Okay.
this orientation, right? In this orientation. How about this orientation? Where the half sphere is there, above the XY plane. Wouldn't phi go from 0 to pi upon 2?
Okay.
If I could draw things, can you imagine you've got the floor and you've only got the hemisphere like a sci-fi city, right? A big dome.
Yeah.
You're describing that shape. Won't the thetas go 0 to pi? But won't the phi only go from 0 to the XY plane, which is halfway?
Wait, so theta would go from 0 to 2 pi in that case?
Yes. Yes. Because isn't the entire floor being used? And the entire floor is a complete circle. And theta is the movement on the floor. And phi is more like the movement vertical, right, on the z-axis direction.
Okay, so to put it, theta is the movement in xy and phi is the movement in the z.
Yes,
Would that be correct?
yes. Does that help you visualize the restrictions? Good. What you
Yeah.
said is correct. Right. So it does matter orientation, right? You know, which bit of a sphere you're talking about, how the values of theta and phi change, right? Like a sphere that's a dome is different than a hemisphere that's on the right or the left. Right, so this fella is going to go 0 to pi upon 2. And this fella is going to go 0 to pi upon 2. And this fella is going to go 0 to 3. And this fella is going to be e to the, oops, rho squared. And then you're going to go, ooh, that's not good. Let me check question 12. There's something not right. Ah, now something's right. There's an X there. And what that X is going to do is going to introduce another row, a sine phi, and a cosine theta. So if I split these guys up, theta is 0 to pi upon 2. There's a cosine there. If I do the phi's from 0 to pi upon 2, I think there's just a sine phi. And if I do the rho from 0 to 3, there's now a rho cubed e to the rho squared d rho. So you get a cosine theta, you get a sine phi, and you get this fella. Right, that little scrunched up mess is X. And that's e to the rho squared, and that's essentially the dv part. Okay, there are two good ones and one horrible one. Would you agree these two are pretty trivial and easy to do? They're just a sine and a cosine. On the other hand, we're going to have to figure out.
How come it wasn't phi squared sine when you put in dp d theta?
Oh,
dp, d
because
theta?
Yeah.
because I missed this fella. Thank you.
So the sine.
Oh, we know how to do sine squared. Can we call it a half 1 minus cosine 2 phi and we're good? Yeah, welcome. I'm so interested in this, I wasn't paying a lot of attention. Right. I need rho cubed e to the rho squared d rho. Right. I need to get this guy. I need a strategy. Calc 2. What could you do? There's two possible ones. One works and the other doesn't.
U substitution? No, I didn't mean to say that.
No, you did mean it. Keep your gut feeling and say that. It is a U substitution. And who's your u substitution going to be?
Rho squared.
Yeah. Now, you talked yourself out of the right answer because you do what you should do is you try and think through and what would happen if I did that. And you said, oh, not good. I've got a rho cubed there and that's not going to go away, right? I'm just putting thought process into your brain here. Let's take this and see if we can make it happen anyway. Crossover. Isolate. And superficially, at least, it looks like we've got problems. We've got a rho cubed, an e to the u, a 1 over 2 rho, and a du. And it looks like we're going to have a half rho squared e to the u du. And you know that you shouldn't have rho's left over, right? The variable in this case is rho. You shouldn't have anything with a rho left over, and we've got a rho squared left over. But can't you, if you're lucky, can't you replace rho squared with something with u? In fact, exactly with u. Which means that we now have this guy. How are we going to tackle this guy?
That an integration by parts?
It is, and 10 minutes later, you'll have the answer. So you can imagine that little integral is probably going to take you more time than everything else you did up to that point, because these two should happen really quickly. I would open this one. Pretty messy. Are we good with that thing? Nothing that you have done in Calc 2 integration wise is not going to get used somewhere, right? It's almost like everything appears somewhere, especially in this trig stuff. Okay, time for one last one. Triple integral again. Oh, wait a minute, I just did that one. Hey, we're getting there. Triple integral of the square root of x squared plus y squared plus z squared dv. And E is described as above a cone and between some spheres. Oh, that's good. It takes longer to write it than it does to do it. Okay. I need to figure out E is. That's all I've really got time for. Rho theta phi. Between these two spheres is essentially telling me that rho is between 0 and 1. And that's good. Done its job. Z equals x squared plus y squared is a cone. Because they told me in the description it's a cone. But that's not really in a very useful format. So let's see if we can make this something nicer. Well, how about z squared equals x squared plus y squared? That's nicer. Where's my x's? Z squared is rho squared cos squared phi. X squared is this fella. And y squared is this fella. Okay, now, essentially what we want to do is we want to turn the equation of this cone into what it would be in polar, right? That doesn't look too promising, but it will get nicer. Can't you pull out this as a common factor? And if you leave these two guys behind, that's a theta at the end, don't you get 1? So bottom line is you get that guy. Now let's make the assumption that rho isn't 0, which it clearly isn't. Then can't I divide both sides? By rho squared. Okay, where can I go next? I want this to be as pretty as possible.
Well, you could divide by either cosine or sine to give you tangent.
Okay, so we'll divide both sides by cos squared, and that will get me tan squared. You agree? Sine squared over cos squared is tan squared. And again, I'm making an assumption, but we're not going to be looking at negative values of phi, right? They only go from 0 to pi, that's it. And so I don't need the -1, I just take square roots. Wait a minute. Isn't a cone just all the points whose phi is, in this case, pi upon 4? So that tells me it's it's above the cone. And we had this above issue before, isn't it, that guy? Now, on the
Yes.
floor, is a cone a circle? A sphere is definitely a circle when it hits the XY plane. Isn't a cone also a circle when it hits the XY plane? Right, vertical cone, right? So, doesn't
Yeah.
that tell me nothing happens to the thetas?
Okay.
Okay, so you take these restrictions and you stick them in here. Won't this guy just turn into R?
Yeah.
And then you'll have 3 variable separable things, rhos, thetas, and phis, your power rule, and a couple of simple tricks. But unfortunately, that's all we have time for. So I was hoping to get this done. That was me being over optimistic. But we are darn close to being done. So
Is
when I
this an
see,
example of number 13?
yes,
Oh.
this is an
Okay.
example of not number 12, but number 13.
Okay, thank you.
So we see you tomorrow. We'll finish the rest of these guys off, and that will be spherical out the way.
Thank you.
You're welcome. Bye-bye. I'll hang about for any questions you may have.
Okay. I have a question, Professor.
Yes.
Can you go back to the last example, please?
I will do that. So
Okay,
have a look at it.
I have a couple of questions. Okay.
Yes.
So if in this example, if there was a restraint to the first quadrant, so that will mean that theta will be the one that will change then. So that will
Yes.
mean that it will be from 0 to pi in that case if it was in the first quadrant, correct?
If it's in the first quadrant, it's here, right?
That's correct.
First quadrant, it's here.
Right. So it will
So
be
the
0
restriction would be 0 to pi upon 2.
to pi upon 2, right? Okay.
If they had said, no, x greater than 0 or y greater than 0 or first octant or something else, it would affect the theta value, and you would just go in and see in what way it would affect the theta.
Okay.
But in this question, it's the whole circle is getting used.
Yeah.
So the theta to 2 pi is good to go.
Okay.
Right.
And
in this question here, and they did a between, but see if they just did a total single sphere.
Right.
The only difference would be 0 to 2 or 0 to
0
1.
to 2. 0 to,
Yeah. That wouldn't have changed. It would have changed the row, but not significant way.
Okay. Okay. And the phi ranges, the phi range is always between 0 and pi.
It's always, well, it's because they used the word above.
Okay. No,
If they'd used the word below, it would have been pi upon 4 to pi.
Oh.
Because you're talking about above, you're talking about above the XY plane, right? The high bit.
Right.
So 0 to here is the above piece, 0 to pi upon 4, right? Now, if you want below, it's the pi upon 4 all the way below it, right?
Okay.
So the word above and below does make a
Okay.
difference. As far as I can tell, we don't have any belows in the homework. They're all aboves. So that makes it a little bit easier because they're all going to be 0 to pi upon 4, pi upon 2, whatever it happens to be.
Okay. Okay.
Okay.
All right. Thank you, Professor.
Any other? You're welcome. Any other questions from anybody?
No, just hanging out.
Okay. Then I shall see you all tomorrow, guys.
Have a good day.
You too.